Morning, everyone. Welcome to Cloud 201. I'm not going to read the title. It's a little bit long, but I'm sure you've read it already. This is a follow-on from our Cloud 101 session. We might touch on some of the same topics again, but we're probably going to rush through them quickly if we think they're important enough to cover twice for those that didn't come to 101. Introductions, my name's Levon Kennedy. I'm a pre-sales consultant based out of Melbourne, Australia. I look after sort of enterprise customers in New Zealand and parts of Australia. And with me I have Russell Christopher. Do you want to introduce yourself?
I would love to introduce myself, Lee.
Good.
Thank you. Hi, I'm Russell. I'm a product manager focusing on the cloud. Been with Tableau 6-7 years, and I like the cloud.
Cool, easy. All right, I'll give you 10 or 15 seconds to read the agenda, but really the takeaways today, we're going to talk a little bit deeper on choosing the right instance type. We covered this at a high level yesterday. We'll talk about taking content from on-prem to cloud. We'll talk about some connectivity stuff. We'll talk a fair bit about automation, because that's kind of the end goal for a lot of people. And we'll talk a little bit about multi-node deployment as well.
Oh, questions? We have lots of stuff to talk to you about, so please table them to the end, so we make sure we get through the content.
Yeah, good point. There's a lot of content to cover. If there's a question that we didn't cover that you have, come up to us, ask.
I just said that, hurry.
All right. Why did I choose Russell as a co-presenter? All right, so Tableau on Cloud is pretty easy when all you need is a credit card, really, and you just need to read one of our white papers on Azure and Amazon. There is one for Google coming as well. If all you're aiming for is a basic single node deployment, standard default install, that's pretty easy. If you've got basic IT skills, can remote desktop, you can do that in an hour. But it starts to get a little less easy when maybe you want a clustered Tableau Server instance with, spread across different subnets with connecting to cloud and maybe on-prem data sources and on-prem connectivity. And you want to start to add automation for deployment and monitoring and so forth and integrate with the cool stuff that the cloud offers. So this is a little bit less easy, but this is really the end goal where a lot of us want to get to. So we're going to touch on some of the important topics in this area today. If you think we've missed something today, maybe we're not talking about it because it's identical for on-prem. We're really going to be trying to touch on things that are really mostly relevant to cloud deployments, and we're going to try as much as possible to ignore stuff related to on-prem or stuff that doesn't matter if it's in the cloud. And we're going to talk about the big three, Amazon, Google, and Microsoft today. We're not going to talk about our SaaS offering online, and we're not going to talk about some of the clouds that are popping up in other regions like APAC, like Baidu and Ali and so forth, or Rackspace. We're going to talk about the big three. If you're looking for an online specific session, there are online sessions running specifically to cover that. All right, let's jump into instance sizing and load testing. Some of you will have seen some of this yesterday in 101, but we'll go a little bit deeper today, and we'll move quite quickly. These are the sort of topics we're going to be talking about. And we're just going to start with a quick refresher. Minimum installation requirements for prod, 8 cores, 32 to 64 gigabytes of RAM, which means 64 gig if you can, and at least 50 gig of free space. If you're looking for if you just want to deploy Tableau Server on the cloud and get started with an instance, that's a really good choice. On any of the 3 platforms listed there, that instance is a pretty good choice to start with. All of them give you 16 vCPUs and 64 gig or so of RAM.
One thing to note on this is that the Azure instance, the D16 SV3, that's a relatively new instance type. It is not available on all Azure regions, so you need to kind of go and look for it, but it's a good choice.
It's available in Australia, so it's probably available most places though. Cool. And quickly, not all vCPUs are equal. Or when we list specs for Tableau Server, we say you need 8 cores, which as a minimum for production. Most of the cloud providers list in vCPUs, and generally 2 vCPUs is equal to 1 core. There are exceptions. Some Azure instances, 1 vCPU is equal to 1 core, but some of the newer instances for Azure, like this D16S, is actually a 2-to-1 ratio. So make sure you test, and we covered this yesterday as well, but it's worth repeating. Use this WMIC command. I'm not going to show it today, but it literally takes 2 seconds to run, and it will validate if you've got the ideal number of cores for your Tableau Server environment. So this little area here, when you run this command, number of cores, this is exactly what Tableau Server Installer will detect when it goes to install. So you want that to show 8 or more. All right, summary of selecting a disk. Amazon, Azure, and Google, all of these providers have an aspect of disk performance that is somewhat tied to the size of the disk. So the bigger the disk, the more performance in general. The way they're set up in each provider means that there's slightly different things, slightly different sort of things you need to focus on depending on the provider. It's not one rule for all of them. For Amazon, general purpose 2 or GP2 SSD disk, you want to start with at least 100 gigabytes. Azure, you want to have a premium storage. You have to select an instance type in Azure with an S attached to it. If you don't get an S instance, you'll never be able to attach premium storage to it, and you'll have to start again. Google Cloud, SSD persistent, just their sort of standard SSD is a good choice, and you'll want 200 gig or above. Some of these sizes, a P20 disk in Azure, for example, is 500 gig or 512 gig, and you might be asking, this seems a little bit larger than I typically start with for a Tableau server, and it's because it ties back to get the minimum expected performance for the disk for Tableau, you have to start slightly larger than you otherwise would. We can cheat a little bit with Amazon because of this thing called burst balance. And I'll build this out. Basically, oops, too far. Burst balance for GP2 in Azure, when you deploy the disk, you get a baseline level of performance. You get 3 IOPS per gigabyte provisioned. But what Amazon lets you do is it lets you burst to a much higher level of performance for periods of time. And you get these sort of virtual tokens attached to the disk automatically. There's nothing you need to do to get these tokens. There's nothing you need to manage. But you can spend these tokens for periods of time, and then they refresh when you're not using the disk as much. So you can sort of cheat and start with a smaller disk in Azure because you have this burst availability that you can use up. The burst availability refreshes at a similar rate, 3 IOPS per gigabyte provisioned. So for those of you doing the math, if you have a 1 terabyte disk in Azure, you never run out of tokens, so you can burst forever. What we have here is 2 charts. The chart on the left is from TabJolt, our load testing tool, which we'll talk about in more detail later. On the right, we have a chart or a screenshot from the Amazon CloudWatch metrics console. So this is a metric tied to our instance on the right-hand side, and it tells us the percentage of burst tokens that we have left. So in this case, at the start of this chart, we had about 10% of our burst balance left, and it's increasing up to around 20%. Which means our disk is not bursting at the moment because we're slowly regenerating tokens to burst later. Before I move on, these charts aren't for the same time period, they're for illustrative purposes only. But on the left-hand side, what we see in the red line, a higher red line is better. This is a load test, so the number of tests that we can complete per minute, a higher number is better. And what we see at the start of this, what we see at the start of this run here is a very low level of performance in terms of tests per minute compared to the previous run in grey in the background. And the reason for this is when we started this test run, we'd actually exhausted all of our burst credits. And you can see as the test progresses on in terms of about 10 minutes, we start to renew some burst credit and the performance shoots back up. So this is an important metric to watch because when Tableau Server gets hit hard, and if you do run out of burst balance, you can see a significant drop-off in performance. Similarly for Azure, again, we talked about starting with a P20 disk, which is premium storage. It's quite, it's relatively large for a starting point. It's 512 gig. An alternative, if you want to, is to start with smaller disks and stripe them. Typically, this is not a cloud thing really, but striping disks is going to give you more IOPS and throughput, more performance. So this is an alternative as well. Obviously, it comes with slightly more administrative overhead, but the option is there to start with smaller disks and stripe them. Disk metrics. Same as physical, but this is worth touching on because it is important for Tableau Server as well as CPU and memory. We want to look for latency, throughput, and disk queue length. These are some of the important metrics to watch. Anyone done sort of DBA performance monitoring as well? Similar metrics that you want to watch out for. Tableau, we're looking for a latency of less than 20 milliseconds. We don't really want to spike above that too often. Throughput around 100 megabytes a second or more. And let's have a look at how this looks. So this chart here is on the left-hand axis, so on the only axis rather, is milliseconds. This is disk latency. This is just a Windows Performance Monitor screenshot from an instance that we had running, and you can see that the latency starts to spike up above the 20 millisecond line in the middle of this chart. That's extract refreshing happening. So when you put a heavy load on the machine, like extract refreshes, or like a large amount of extract refreshes, latency can spike up. But as long as it drops off afterwards, and as long as it drops off during user time, that's okay. If it spikes up during extracts or overnight when people aren't using it, that's generally no problem. What is a problem is when it's like this and it's constantly pegging off, over 100 milliseconds, you might think this is probably never going to happen. I've seen this happen more often than I'd rather talk about at clients, and it leads to very poor user experience. So if you want to have a good user experience, focus on disk, but also focus on CPU and memory. Disk metrics. To monitor your disk metrics, Tabmon is an amazing tool to let you correlate what's happening on Tableau Server, how many user sessions do I have, what are they doing, what is VizQL doing, with metrics from the virtual machine like latency, CPU, memory usage, and so forth. Tabmon is a free tool. You can download it from GitHub. If you just Google Tabmon and GitHub or just Tabmon, you'll be taken straight to some of the learning pages and download pages for this. But what we can see here is up the top in gray, we see the performance metrics directly from Tableau. Tabmon talks to the processes that run on Tableau Server over JMX, pull some of the metrics back like VizQL sessions open and so forth, VizQL sessions at work. And we can see that as the VizQL sessions spike, we also see a correlated response in the disk performance as well. So this is an awesome tool to correlate your user experience or what the users are doing with what the underlying server is doing. Cool. Talk about load testing, which is Russell.
I get to talk now.
You get to talk.
It's been so hard for me to be quiet. Yeah. So you learned about compute, you learned about storage, et cetera, et cetera. So what? Right? Your users don't care about any of this stuff. So a big measure ultimately of success is the perceived performance of the server. Are your users happy? Right? And so you don't typically want to open up a server until you have a feel for whether you are delivering good perceived performance. You're typically going to do that with some sort of load testing. Any discussion of server performance is not complete without this white paper. All of the tweaking and things that we're talking about now and showing you sort of pale in comparison in terms of their effect on user experience compared to this. So a well-designed workbook running on Tableau Server is going to be much more performant than a poorly designed workbook, and you've tweaked the hell out of the server. Okay, so this is something where you really need to focus because it makes everything either very easy or very difficult for you to deliver on that user experience. So if you're not familiar with this white paper, you really want to download it, read it, internalize it. And now on to load testing. We use TabJolt. I suspect that everyone in the room is familiar with it. Great tool. If you are not familiar with it, never fear. There is actually...
Unfortunately, it's in
Oh
the
no,
past.
yes. Well, we actually have a time machine, and we will allow you to go back in time and visit this class and learn all about TabJolt. We also have a hands-on lab, actually, where you can go and set up a server, or we've set it up for you. You have an injector, and you get to beat the hell out of Tableau Server with it, which is kind of fun. So if you're not familiar with the tool, take some time and learn about it. At the highest level, I like to use this tool to discover the best combinations of storage and compute. You make a change, you fire TabJolt, you see what the number is, you make another change, you fire the tool again, you see what the number is. As we already said, it's available on GitHub, just like Tabmon, supported by the community. A couple rules of thumb. You really want to use a representative workload. If you do all this work and then you just point TabJolt at the sample workbooks that come with the server, you're wasting your time. Right? If you do load testing and you're only rendering vizzes, when in the real world you also have extract refreshes going on, you're wasting your time. So really think about what people do on your server and try and replicate that when you're using the tool. That also includes some settings on TabJolt. By default, it will pound the server as fast as it can. It doesn't pretend to be a user. You know, a user is going to look at the dashboard for a little while. They're going to think about what they're seeing, and then they'll do something else. TabJolt doesn't do that, so you'll need to tell it to do that. And you can also adjust things like the percentage of users who just look at a dashboard versus the percentage of users who look at the dashboard and then maybe choose a quick filter or select marks or somehow interact with the dashboard. So use all those knobs and try and make it a real-world workload. Just like Tabmon, it is going to capture CPU, memory, disk throughput for you automatically, and you can look at that stuff afterwards. You will see some errors. Errors are okay, actually. Some things that we consider errors, like a long-running viz, will show that as an error because we consider that a poor user experience. But actually, everything worked the way it was supposed to. It just kind of took a while for it to finish off, so don't worry about that. And again, you just want to try out different instances, try out different configurations, etc. So I'm going to give you some real-world learning here. This is, again, my workload. It's not yours, so your mileage may vary. But in general, what we're going to show you here pretty much holds true. We did 2 workloads. One was very viz-centric. I want to render a moderate to heavy number of vizzes. And we did that on an M4 4x large. That is the general purpose machine on AWS that we like a lot. And we also did an R4 4x large. That is the memory optimized machine. It has twice as much RAM as the first one, but its CPU is not quite as good as the general purpose machine. Okay? The second workload that we did was just like the first, except we were also doing extract refreshes during that test. So it was maybe a little bit more real world. Here's what we found. The R4, when you were only rendering vizzes, was better. It delivered 10 to 15, maybe a little bit more throughput in terms of rendering stuff. However, when we started doing other work, like refreshing extracts, then that general purpose machine, even with less RAM, because it had a better CPU, actually did better for us. So this is the sort of stuff that you can learn, and especially if you're doing a distributed deployment, it's actually really useful because you might stand up your instance that only is running VizQL server processes on it as an R4, and if you have a backgrounder-only machine that you use for refreshing extracts, you might make that an M4. So this is why this stuff is so valuable. Same 2 tests on the bottom. We also wanted to understand if I want to buy more Tableau, should I add new machines or should I take my existing machines and scale them up, make them beefier? In this case, both times we found that horizontal scaling, more machines versus making my existing machines bigger, was the best way to go. And we'll show you some numbers around that. Let's see. In fact, we will show you some numbers around that right now. Let's get in here, and we will jump into Tableau. OK, so the first thing that I'm going to show you is, oh, I don't think I even need to reconnect. Let's see if I can get away with this. Oh, phooey.
Live demos, right?
Live demos. And I don't know how to shift F5. Will you fix this?
Yeah, my laptop.
I don't know how to use this Tableau thing anymore. It's, I've heard it's really easy.
I'm just going to turn it off and on again because that usually works.
OK, very good. So, how about those Yankees? OK, oh, good, a Yankees fan. Good.
I don't know what that is.
Yeah,
okay.
I know. Don't worry about it.
I'm not.
It's like, I don't know, cricket or something. You guys play that, don't you?
Some people do.
Do you have sports in Australia?
Yeah, we have sport. We have
Okay.
Australian rules football.
That's where the guys just beat each other up, right?
Yeah.
OK.
You honestly didn't take a drink for the demo gods.
No, I didn't.
No.
I didn't have a drink for the
No.
demo gods this
OK,
morning.
cool.
Okay,
Awesome.
next time.
All right, so the first thing that we're looking at, we were curious about, given an 8-core machine, let's say I have a single machine that has everything on it, what would happen if I add another worker? Now, this is sort of an interesting wrinkle. On our primary machine and our worker, we're going to change something. Normally, we put some stuff on the primary and it does work. We stripped off most of the processes from our primary. It's only running the repository service, a gateway service, and maybe search or something. And when you only run what I will call non-valuable services, from a licensing point of view, it's actually free. You don't have to pay Tableau for that. And so we thought, okay, well, if all I'm doing is paying for some extra compute to run that primary on, maybe it's a good idea to try and run an architecture like that. Is there a difference? And indeed, there is. Here is a single primary machine. Now, what we're looking at is, since this is the first time, this is TabJolt information. This top one represents transactions per second, throughput. How much stuff am I able to do? We saturated about here, meaning as we're adding more and more users, we're doing more and more work until we get to this point, at which point we can't do any more work. The machine is saturated. We want a low response time, which is this second chart, and we want a low error rate, although we're not too worried about error rate. So this is the primary only. Now we're going to add a worker instead, and we get some extra one right. You can see that we're able now to handle more users simply by offloading the repository from that worker and having it run on the primary. So that's a good thing. Now this next one we haven't even talked about, but it's something that on the cloud can be relatively important. A lot of our customers, especially who are doing distributed deployments, want to have all of the processes that communicate with each other do so in encrypted fashion. That's part of AWS's shared security model, for example. We don't do that by default on Tableau Server. It's on our backlog. It's something that we'll get to fairly soon. But if you want that, you turn IPsec on at the operating system level. So at that point, everyone asks, well, isn't that going to impact performance, right? Well, let's find out. We went ahead and we ran 2 machines without IPsec, no encryption between the 2 machines, and that's sort of what we saw, right? Then we turned IPsec on at the operating system level on both machines, and here's what we saw. No difference. So lesson from this is if you want to encrypt your network communication, go for it. There's no cost. We also then, this is sort of default settings. We thought, what would happen if we went absolutely crazy with the IPsec, turned it on to NSA, paranoid, schizophrenic, black helicopter settings, like all the way over? Does it make a difference? And essentially, it does not. Even at the highest level, here's no IPsec, and here's IPsec for everyone who's watching me type people. No difference. So turn on IPsec if you want to. It's awesome. Now, this speaks directly to what we were talking about yesterday. We are going to talk a little bit about 16 cores, right? I have 16 cores of Tableau Server. How do I want to deploy that? Here is 16 cores on one machine. So this is the scale up. This is monolithic server. And you can see already this is a loser in terms of my workload. Now let's split that between 2 8-core servers, longer runway, so clearly 2 8-core machines is better than 1 16-core for my workload. And then I did something that Tableau support people do not like. I did 4 4-core machines. We want you on 8-core machines generally. And the reason, if nothing else, is typically on a 4-core machine, you're going to have a lot less RAM. And even if you have great CPU, you also have to have enough RAM. So what I did is I kind of cheated. I only put 1 VizQL server process on each of these 4 machines so that we wouldn't consume as much RAM as we would if we had 2 or 4. When I did that, look at that, like clear winner. This actually works really well. So conventional wisdom is good. You generally want to follow what's in help, but I get more throughput, lower response time. I mean, look at some of these on the others, and no errors, essentially. So this is kind of cool stuff. And I think at this point, I hand it over to you. One VizQL server and one cache server on each machine. Yeah.
Very cool. All right, let's talk about automation. Really, we're going to cover some of these questions. I'll let you read this. We'll move on. The end goal for automation for a lot of people is, can I just like press a button or run one command on a command line and get infrastructure, Tableau Server configured and my networking done and so forth, and then have it ready to go. That might be what it means to some people. Some people might be in between. We're going to talk about full automation infrastructure and Tableau. We're going to talk about the Tableau only part, and we're going to talk about the install flags as well. So we're going to talk about a few different levels of automation. Let's address sort of one of the elephants in the room. Can we have Tableau be elastic? Can we add nodes with our cloud provider in response to load? Can we scale things up or out horizontally in response to load? Unfortunately, today, the answer is no. Okay, there is no elasticity with Tableau Server on the cloud today. Some of the cool stuff you saw in the Devs on Stage keynote yesterday, like, what's it called? The
TSM?
TSM, Tableau, sorry. I didn't have it. Yeah.
I thought you were being facetious. You actually forgot for a second.
Thought I'd ask the product team. TSM, Tableau Server Manager, that lets you do hot changes to Tableau Server architecture, are some of the things along this journey to allow us to have elastic deployments. Okay, so we're working on it. It's on our backlog, but not right today. But we'll start this with a demo. What does an automated deployment look like? We sort of touched on the surface of this in 101, but we didn't look at how it actually runs under the covers. And then we'll jump into what are the parts that make this work. Oops, do not open Outlook. I really didn't have enough shots for the demo, gods. All right, I'm already logged into Amazon. I'm going to bring up our automated deployment script, just our starter one. I'm just going to Google this because I didn't leave it up before. But we're going to do an Amazon one. We can quickly look at a Google one as well. Yeah, this mouse. There we go. So this is our Amazon automated deployment script. We have a couple of different versions of this. We have one that also deploys a Redshift database and a Postgres database and Tableau Server. But this one just deploys Tableau Server. It deploys a 3-node cluster in Amazon with an external load balancer and a Bastion host for administration. And for those of you paying attention or looking at this, you'll notice that we've actually deployed the workers across 3 different availability zones, which is typically something we recommend against in on-prem deployments. This is like deploying Tableau Server nodes in different data centers. But because the latency between our data centers in cloud providers is typically so low, we can get away with this, and it gives us the upside of a little bit more redundancy. So if you want to test this, all you need is an Amazon account, and you can come here and say, let's deploy a cluster into a new virtual private cloud. It comes up with this page. We have our template or recipe for this deployment. We'll look at one in a minute. Already ready to go in S3 or object storage. I'm going to click on Next. There we go.
It's a little slow.
No, the mouse is a little bit. Anyway, and what day is it? It's Wednesday. We're going to select the availability zones or data centers we want to deploy into. I'm going to add a network range for whitelisting. This is like, what range of networks do I want to allow to connect to this Tableau server once it's deployed? To be more secure, you might only allow the range of addresses from your corporate environment. Optionally, I can add an SSL certificate here and have SSL automatically applied to my load balancer. I need a key pair. I'm going to specify a password and a Tableau license key, of course. There we go. This license key is only valid for like 2 more days, so feel free to write it down. And we'll try and fill this in as quickly as possible. There we go, industry tech. There we go. So if this looks familiar, it's because it is. This is the same information that you would put into that registration form that pops up when you install Tableau. But we're going to configure it automatically in the background. You can click on Next. When you're starting out with these automated deployments, the providers typically have a setting, and this is the way it's referred to in Amazon, called rollback on failure. Basically what this means, if you've made a little mistake in your template or in your script, will the cloud provider automatically deprovision and delete everything if it has a failure? You typically don't want this when you're testing and learning, because if there's an error, you want to be able to jump into that error and find out what it was. If you have this enabled, the error will be wiped away with the rest of the infrastructure. So think about leaving rollback on failure on no when you're starting out with this. Okay, and we're going to create this. I already have one that I created earlier. You can see all this create complete means my stack or all of the resources within this automation template have been deployed successfully. But if I refresh this, you'll notice that this new stack is currently create in progress. So it's starting to do things like create the virtual private cloud for me, and then it's going to move on to creating security or firewall rules and creating the 3 nodes that need to exist in my Tableau cluster and so on. And we're going to see this build out over time. When it's finished, the cool thing is in a lot of these, you can automatically output stuff to the GUI or to the interface for the cloud provider. Now this is complete. This is the one I pre-baked earlier. It actually tells me that we're finished. It's all ready to go on this URL. And if I could use this mouse properly, there we go. I can simply open this URL, and Tableau Server should pop up in a minute. There we go. So this was deployed, 0 touch from me aside from putting in my registration details. And there we go, ready to go. Cool. Let's have a look at what's going on under the covers here. What's this built on top of? So this is built on top of a few things. It's built on top of installer switches, which you've all seen before on any other application. You can say like /quiet, /silent install for an application. It's built on top of install scripts, which help manage some of the admin stuff around like firewall rules and making sure it has the packages we need to install Tableau and parse XML and JSON and things. And it relies on infrastructure as code templates as well. We'll talk about all 3 of these. So installer switches are just Tableau Server installation file. You can do things like put /silent in to make it install without prompting anyone. You can set the installation directory and accept the EULA and so on and so forth, automatically register Tableau, just with installer switches with the Tableau installation. By default, it will just install with the Tableau Server default, so like a next install. And it's pretty basic. It just looks like this. So Tableau Server, /accept, /very silent, accept EULA, etc. Where do you want to install it? Where does the configuration file come from? Very similar to other applications. Going a little bit more deep on the automation, we have Tableau installation scripts. These are available on GitHub. It's a Python script, and it automates the process of accepting configuration parameters from the user, validating configuration files are complete, taking registration details, and so on and so forth. And this is typically what most of our automation scripts are built on top of, like our Amazon Quick Start deployment. That is built on top of this deployment script. My Google Cloud deployment script is built on top of this as well. So this is a great base script to start with when you're looking to automate installs of Tableau Server. What does it look like? Python, then we have this file called scripted installer from GitHub, and then we just say install, and we pass in a number of command line parameters that say, where do you want to log stuff? Where do you want to install Tableau? Where is my secrets? My secrets are my domain username and password, or the username and password I want to run Tableau Server as well as the default admin password for Tableau. How do I want to configure Tableau, registration, and so on. It also does things in the background like opening firewall rules in Windows for you, optionally, if you want to, and a few other sort of make your life easier tasks in the background from this single Python deployment script. The configuration file, this is a YAML configuration file. This is what Tableau Server uses to work out how many gateways do I need, how many data engines should I turn on, how many VSQL servers should I turn on. This looks a little bit daunting, but it's really not. The easy way to figure out what you need is to do a manual installation, configure it the way you want, and then copy the existing tab svc YAML file from your Tableau Server deployment and bring it into your automation. So deploy manually, because you have to understand what you want first, generally, before you start to automate things. So don't worry too much about getting this right. You can copy it from a manual deployment as well. All right, infrastructure as code. So we talked about how do we install Tableau, the software. But we also need to provision infrastructure automatically as well. And there's a few different ways to do this. All of the 3 cloud vendors have their own sort of automation framework or recipe framework for deploying infrastructure as code. And it is basically a recipe or a template. You just say, I want a machine of this size deployed in this network with these firewall or security rules associated with it. and the underlying cloud provider will work out what it needs to do to make that happen. So it's a template. It's not like a script that's you call APIs and have to do things manually. You just tell it what you want. There are also, your, I want to say traditional, but more agnostic automation tools like Puppet and Chef. They also have hooks into Amazon and Azure and these other platforms for deploying infrastructure as well. And there are some sort of sample community created, I think, for Puppet, for Tableau Server deployment out on the internet on GitHub as well. So in our server documentation now, we are documenting the prereqs for automated install. So if you're looking for some base level information on getting started with this, the server documentation is a great place to start. And if you want to get an idea of what the sample installation script looks like, again, it's on GitHub, fully available to look at. And it's just quite a lengthy Python script that helps us determine are things in a valid state for configuration before we kick off this installation? Have they provided a valid registration file and a valid secrets file and so on and so forth? And you can use this not just with Amazon, but with other cloud providers. So with Google's deployment manager, I did a Tableau Server deployment this morning, which did a similar thing, deployed network file, rules, and a Tableau Server instance. So I have my Google virtual machine instances here that was automatically deployed. And I'm just going to use the trackpad. There we go. Problem lies with the user. And again, we have an automated deployment of Tableau Server on Google. And this was based on top of our Python installation script. So the Python script is a great starting point for automation tasks. Cool. Quickly talk about content migration. It's relatively similar to, well, it is very much similar to how you would do a content migration from from an on-prem server to another on-prem server. We have a couple of options that are really good for this and really simple. Backup and restore for Tableau Server is an awesome way to get all of your content into another server really quickly. Site import export is a great way to get part of your content, like a single site. Those are both fully supported and documented. But say you don't want to use either of these and you just want to slowly migrate a selection of workbooks up to your cloud instance. There is a tool called TabMigrate that lets you define a list in a text file in a CSV of workbooks you would like to migrate from on-prem to cloud or from server A to server B, and it will just automatically go through that list and move them to the cloud. We'll talk about some other things later, but some of the other things you'll want to think about is if you've got on-prem databases, you'll need to make sure that they're accessible from your cloud provider with something like a VPN or making it accessible over the internet or a direct connection. But we'll touch on that later. All right, and now I get to hand over again.
So I'm going to move relatively quickly. We're running a little bit behind, but backup or archiving, great when it comes to object storage, right? Object storage, it's cheap, it's durable, right? 2 cents and a little bit more per gig, for example, without a discount. So 100 gigs of archive, $2 a month, right? Awesome. Highly durable, 11 nines, good stuff. Before I get too deep into this, I'm going to do one thing. I want you to pretend that you do not see me doing this. We're going to get into Tableau Server, and I'm going to log in. I'm going to log in as Jack. Jack actually does not exist. I'm also going to log in as Jill. Jill does not exist. I will log in as Tableau. Tableau does exist, but wrong password. And now let's go ahead and see if I can actually do it correctly. Do it a little bit more slowly. Nope. Oh, boy. Oh, boy. All right. See, when I'm in a hurry, now I remember what I did. I have 3 variations of a single password, and I was putting the wrong one in. All right, we'll go ahead and kind of knock something out. Okay, awesome. So you didn't see that just happen. Back here. So back to backup. Object storage, good. Very easy to use these design patterns via the tools that the providers give you, whether it's CLI, whether it's the Boto 3 library, and you want to write a little code, maybe some Python that lives on the local machine, or you want to throw it out in Lambda, let's say, and go serverless. It's pretty straightforward. What I like about this the most is once you have stored your stuff out on the cloud, it's accessible everywhere, right? So it dovetails quite nicely with a lot of corporate policies around DR and backup saying some of this stuff must be offsite, right? It's very easy to do this, and it is offsite and easy to grab wherever you are. So at its most basic, something might look like this. What are we doing here? This is a little bit different. Oh, you put some new stuff in here. Don't surprise me like that. Basic script that is running on my machine. Sorry, it's a batch file, right? I'm going to fire it with, let's say, the task scheduler. I'm going to do my tabadmin backup. Then I'm going to fire a command with the CLI tool, like AWS, copy the name of the file, and then a location, my bucket and maybe a folder. If I'm doing Linux, same thing, right? I'm going to use a shell script. I'm going to call it from a cron job. I'm going to do TSM maintenance backup instead, and everything else applies. So this is really straightforward. I can use my script to actually manage, if I want to, a moving window of how many of these files I keep, or all of these object storage offerings give you lifecycle policies. So they can do it. After a certain number of months, maybe I move some of these files to a reduced redundancy level, which is cheaper. Or maybe after a year, we allow that lifecycle policy to delete the stuff just completely because we don't need it around anymore. These are some of the things that are really nice on the cloud platforms that just sort of automate this stuff for you. This is a little bit more fun, though. We're going to leverage EC2 Systems Manager and an agent that, whether you know it or not, actually lives on every Windows AMI that you spin up on EC2. And I'm going to take those same commands and fire them remotely. And this, to me, makes a lot more sense, especially if you have a fleet of Tableau servers. You don't want to have to change that local script file 50 times, right? So I'll feed the commands in. They get fired in parallel across all of my machines at the same time, and life is good. We still throw that stuff out maybe in a bucket somewhere. SSM, as an FYI, cool tool, inexpensive to use. Lots of features. The ones that we care about are automation. I can do things like OS patching or even updating Tableau Server, and run command. Run command is really cool for DR scenarios. In fact, a lot of the lab infrastructure that you guys have been using to do hands-on training, it's AWS. And we took an AMI, a snapshot, essentially, of a deployed Tableau server, just like you might maybe for DR purposes, and we spin them up on 300 machines all at the same time. The thing that a lot of people will miss if you're doing automated restoring of images as a DR approach is that when those things come up on different hardware, it'll be a different machine than when you originally did your backup work. Tableau Server sees that and it says, hey, I'm not on the same hardware anymore. Give me the license key, or I'm not working. So a lot of first-time admins who are doing DR, they'll get the Tableau Server up, but that Tableau Server isn't going to talk to your customers yet. So the run command is a great thing to implement as part of your DR restore process to automatically fire a tabadmin activate command and give the license key back to the almost ready to run Tableau Server. Okay, log file archiving. Why do we need to do it? Compliance, basically, auditing. The repository database, the PostgreSQL database, is pretty good, but it doesn't hold on to the information forever. It gets cleaned out to keep the database relatively small. It also, in my opinion, doesn't give me enough granular information. So I really need the logs, and I need to store them forever if I want to do auditing and worry about compliance. So I'm going to use object storage for that, or maybe even cold storage like Glacier, some really cheap object storage. And then there's some fun advanced scenarios that we can do as well. So this looks very much like backup, right? I have a script. I'm going to save stuff out in object storage. I might just fire tabadmin zip logs to get my logs, or I might, if I'm worrying about the repository, since it's just a zip file, our backup file for Tableau Server, I might just pull the backup of Postgres out of that zip file and store that in object storage. This is the fun part again. I can automate this quite a bit. Same thing that we were talking about before, we're going to use CloudWatch instead. And I'm going to have my little agent on Tableau Server that in near real time is pulling logs, maybe not all of them, maybe only certain logs that I care about, and putting them into CloudWatch. Then I can literally create metrics for myself that I care about based on what's going on in the logs. And I can do things like send out alerts, or maybe even create visualizations that are telling me what is going on the server. So here's an example of a JSON file that is dropped on my Tableau server. It may be a little bit hard to read this, but it's pointing at the folder on Tableau server where my Viz portal logs are. And it's saying grab all of the files that look like Viz portal star.star and save them into CloudWatch on US East 1. That's the region that we care about. And let's kind of look at what that might feel like. So I'm going to dive into the browser. You'll know now why I was logging in earlier. That's the secret is out. And let's take a look at metrics. I have some log metrics here that I created earlier. Oh, you're right, this mouse is just atrocious. I'm going to go ahead and click on metrics with no dimensions, and there are 2. You will see that I have failed login, which means that's the Tableau user where I purposefully put a bad password in, and I have no user. That's another failed login, but because the user actually doesn't even exist on the Tableau server. So I've created my own metrics based on what's going on in the log. If I go into metrics and I choose these, I turn them on essentially. Let me back this out again. I'll go ahead and turn this on. I will go and maybe change this to sum. I want to count the number of times these metrics are firing, and we'll look at this 1 minute at a time and maybe refresh here, and we'll turn this into a stacked array. This is hard. I wish I could do this with Tableau. That'd be really cool. We can kind of see some stuff is happening, right? And I just managed to whack that, but you guys saw a little line there that was developing. So that was me actually logging in a second ago and kind of making mistakes. If I want to, I can also get directly into the logs. So we'll go logs. I'm going to get into a log group. This is where Tableau stuff is. Here's my EC2 instance, the logs from a specific machine. I might have lots of machines. I'll dive in. Here are all of the entries in that log. So this is very Splunk-like, but it's cheap. I might search for Jack. And lo and behold, wait for it. Okay, here we go. And this is across all time, so you can actually see me practicing this yesterday. Let's do this. We'll go to 1 hour ago. That's much better. And here we can see that no user was found for the username Jack. And so the way I created that metric, I just told CloudWatch, look for instances of that string. Easy, right? It's really, really straightforward. And if I want to do something like look for logins, I can say, give me a login and maybe a 401. What is a 401? Does anyone know? HTTP, essentially it didn't work, got a failure. Or I can look for logins and 200, which means the login actually succeeded. Here is that Tableau user finally coming in. And this is also kind of cool. If you see this is the WG session ID. This is how we track people logging into Tableau Server. So I could take this value, right? I could plug it in here, and I could see all of the activities that happened while that Tableau user was logging in. They hit the page, they call a web service API to log in, they're actually logged in, and if we kept on going, we could see other activity. So long story short, this can be really useful. It's very easy to set up as well, and it makes you look smart. Okay, so here is the first thing. We kind of saw this earlier. This is what it normally looks like when people are randomly doing bad things now and then. What if you saw something like this, right? What if you see 100 failed logins per minute with a bad username that doesn't exist? And that goes on for about 2 hours, and then that stops, and then all of a sudden, one user is trying to log in over and over and over again. You would be pretty sure that someone is trying to get into your Tableau server, right? right? So this is kind of a good way to monitor and keep bad people out. All right, so now we're going to talk about it's never going to happen, 11 minutes, things. Things are things that are kind of important, but not important enough to have their own topics. They're just things, and we're going to bang through them as quickly as we can, so we have a little bit of time maybe for Q&A. All right, so first thing, how fast can you do it?
I don't know.
Faster.
Let's talk about on-prem authentication. So a lot of the questions I get is, can we reuse Active Directory on-prem, let you log into Tableau Server in the cloud? The answer is yes. There's a couple of ways to do this.
That's too fast.
Too
I'm
fast.
sorry,
Let's
but that
slow
was
it down
really
a
good.
little
It was a
bit.
good attempt.
Okay. A common approach is to just use SAML. So you can use all the SAML providers that let you talk to your Active Directory and then use Tableau Server with SAML and sign in with the same credentials. Alternatively, there are a couple of direct Active Directory approaches as well. They're both very similar. One of them is a very direct approach, and a lot of these are actually documented by the providers themselves as well. You can replicate your Active Directory domain or your controller to the cloud and then join Tableau Server to that domain controller. Generally, you will want to do this replication actually always across a secure link. So you will need something like a VPN or a direct connection to your cloud provider, like Direct Connect, Express Route, or Interconnect, depending on the flavor or the choice of provider. There is also, rather than this replicate approach, which is kind of heavy, there are these things called AD connectors that are lightweight software agents that you can install in the cloud that talk over a secure connection to your AD controller or to your Active Directory that allow you to add Tableau Server to a domain without necessarily having to stand up a replica of the domain controller. So yes, you can use your existing on-prem AD auth with Tableau Server even if they're in different locations or different data centers.
Cool, hybrid connectivity. I'm in the cloud, I need to talk to my on-prem databases, or maybe I'm on-prem and I need to talk to my cloud databases. How do I do it? This is really just a networking problem, right? There's no magic. You are going to either have a VPN in place. Is a VPN going to be a good idea if you're doing tons and tons of extract refreshes against on-prem data? Right? No, right? Because that pipe isn't big enough. You're probably going to need to invest in Direct Connect or, again, a dedicated connection out to your cloud provider. You can also, the one IT guy in the room is probably going to watch this. He's going to twitch when I say this. You could ask your friendly neighborhood IT people to poke holes in the corporate firewall to allow the cloud-based Tableau server to access the database. And that's when they try and, they come to your cube and they try and kill you. You're probably not going to be able to do this, but occasionally you can. Connecting to Cloud DBs just really quickly. These are not magic. Use SSL, first of all. A lot of people, when they're connecting to Redshift, they don't turn on SSL, which is just, I want all of my database stuff just going over the public internet in the clear. That doesn't make a lot of sense. So make sure you turn on SSL. Use private subnets. If you use a private subnet, that means, and Tableau Server is in a private subnet, the data in your cloud database isn't even transiting the public internet. It's all in the space of that cloud provider. And then finally, use security groups, which are essentially firewall rules to keep everything locked down. You want to do this one?
Yeah, I'll do this one. So cloud databases, there's a lot of different cloud databases out there. Some are cloud only, some are traditional databases on the cloud. A lot of them are low overhead in terms of I can click a button and get a cloud database in a few seconds no matter what it is. However, not all of them are self-tuning or no maintenance. Okay? A lot of these cloud databases still require attention and tuning in order to provide good performance for Tableau. Redshift is a good example of this. We have he has a great series of blog posts on tuning Redshift, and also query services. These are a relatively new type of data service, but basically they let you query data sitting in, say, object storage like S3, without having to run a database for 24 hours a day if you just want to query the data once a week. The gotcha with these query services is that you pay by the amount of data scanned. So if you have a terabyte of data in object storage and you scan all of that terabyte, you pay by the data scanned. And you typically pay about $5 per terabyte scanned, which means that without proper partitioning and a good compressed storage format like Awk or Parquet, You can pay a lot of money by accident with these query services, so be careful, partition properly, store in a compressed format.
Cool. Oh my God, we did it.
We did it.
That's amazing. How many minutes do we have left?
5. Thanks.
Oh, wow.
That was
So,
a lot of content.
Thank you. So questions. We really banged through the stuff at the end. So is there anything that you want to drill down a little bit more into now that we have?
Yes.
Yes, it'll absolutely be posted. Yes, yes, yes. Question. Mm-hmm. Mm-hmm. So the question is, can I split up my Tableau server and put certain processes on certain machines? By doing that, will I speed up Tableau server? Yeah, probably, right? People generally like to isolate workloads. One machine does nothing but rendering vises. One machine does nothing but running extracts. So when extracts are being created, my rendering still is as fast as it always was. Yeah, that's a pretty typical design pattern. Those are generally, the other services like Gateway and Application Server are generally low-cost services in terms of the amount of resources that they use, CPU, compute, and storage. Well, oh, sure. I mean, if you are buying core licenses for Tableau Server and you put it on more cores, you pay for those cores.
But
Just
you
like
can,
if you,
so I think
yeah.
the question is which processes are free from a licensing perspective.
From a licensing perspective, repository, gateway, search and browse service, and I believe the cache server service. All the others you pay for. Yeah, sorry about that. Question in the back.
You mentioned scaling horizontally, all things being equal versus big server.
Mm-hmm. It depends. I've seen a 16 core at low load. The question was, so if I go 16 cores on one machine, what does the performance look like versus maybe 4 cores on 4 machines? Where is the performance actually better? How do I get, on a 16 core machine at low load, you generally will have better performance, right? Because you have all of the resources available to do what you need to. The problem is when you have only one machine, you're much more likely to start running into resource contention issues further down the road when you have more people doing things at the same time. So, you kind of just gotta decide what you're targeting for.
What's kind of the target, a high percentage of, say, CPU memory or whatever, in the cloud, you kind of think maybe I need to start scaling up?
It depends, but the question was, what should I look for in Tableau Server to know I need more Tableau, essentially, which might mean scaling up or scaling out. Generally, 80% CPU utilization, you're right at the point where you're probably about to begin saturating. You'll actually, when you look at TabJolt results, almost every time, right around 75, 80, 85%, that line starts going down on the transactions per second. Yep. And there's a question in the back.
So, well, it's on the same lines. Somebody, you mentioned going out instead of up, and someone else I was talking to was saying Hyper changes that equation, that with Hyper, because of the way it works, you actually want to go up if you're going to use it, and I'm just wondering if it does.
Yeah. So the point is Hyper loves RAM, right? The desktop demo that we saw during the keynote, we all carry around our 60-core laptops to do a Hyper demo on. Yeah, it likes resources. So, but the million-dollar question really there is what you're saying makes total sense, but I haven't seen any numbers behind that yet. So yes, in theory, let's see what the practice is.
I think going back to something Russell touched on earlier, if that turns out to be true, you could have a node with more cores for the data services like Hyper and other nodes with less cores for the viz rendering.
Yeah. Good point, though. Mm-hmm. Yep. The question was, if you're doing TabJolt load testing, are you opening up in your security groups all of the ports, or just keeping certain ones open? I'm going to admit something to you that I'm extremely lazy when it comes to that. And since it's a test environment anyway, I open everything up. Because if someone blows that server up, I don't care. But the correct answer is you probably should only open up the ports that are necessary. Or in your security group, say all traffic, but only from machines in the same security group. And one of the machines would be your TabJolt injector. So you're still keeping other people out, but you're making your life a little bit easier in terms of administration by just opening it all up.
Actually, I have faced an issue where I load all the security ports that are
Mm-hmm.
like all the ports are opening, it was all pretty slow. Then I load on all tasks and everything was working good.
Yep, because, and let's take this offline because it's not really cloud come up afterwards. The short end of the stick is you probably had some ports that were locked down, and TabJolt was trying to get in through JMX and whatever and was timing out, and then eventually just gave up, and it would start doing better.
The other guy who I often find in the cloud is a lot of people I talk to will open the security groups in the cloud provider but forget to do the same in Windows or vice versa. So they'll get one right and forget some of the other ports in the other.
Because the Windows firewall will get in the way as well. I saw a hand go up there.
How do you simulate the extract refreshes with TabJolt?
The question was, how do you reproduce the extract refreshing with TabJolt? You actually don't. You create a schedule that kicks off extract refresh jobs. When I did a lot of heavy extract refreshing, I actually just wrote a little Python script that would shell out to tab command and refresh and extract. And I had it all rigged so I could change, how fast it went and what it called and whatever. So that's kind of a roll your own scenario. Say again? Not yet. In about 10 minutes, I can put it out in GitHub. So yeah, yeah. Back here.
Will you eventually have a Linux version of that CloudFormation?
Yes.
Yes. The question was, are you going to have a Linux version of the CloudFormation template? There is already one in the beta, but it's pretty basic, and we're in the process of creating a much nicer one. Great question. Question in front.
Yeah, to scale that horizontally or vertically,
Mm-hmm.
and let's say you scale horizontally,
Mm-hmm.
do we have a server, like one server with two backgrounder and VCO, or should have two servers with one backgrounder, one VCO, and one backgrounder, one VCO, and four servers with backgrounder, VCO, backgrounder?
Okay. So question is, how should I architect my Tableau server? And the answer is, and I'm being a little bit of a wise ass here, the answer is, I don't know. It really depends on many more variables that you're going to be able to give me in the short term. So the answer to that is really talk to a guy like Lee, who does this all the time. Talk to your rep and say, I need to have a conversation around that. Because
Some of that stuff really evolves over time. Some of that stuff is really hard to predict in a vacuum when you don't actually have users on the server yet. So I tend to try and have customers take a pragmatic approach that this is good today, you might need to change tomorrow. And some obvious clues that you need a server with only backgrounders are running extract refreshes during business hours, because that takes resources away from the people that actually care about getting visitors. So look for clues like that, and it really depends. But talk to your pre-sales person, they can help you architect these things based on your requirements as well.
So the question is, should I use provisioned IOPS, PIOPS, on AWS? Is there an advantage?
Sometimes there is. If you find yourself running out of burst balance on a general purpose volume, that's generally a sign that you should switch to PIOPS to guarantee throughput.
Yeah.
But if you're not running out of IOPS on your GP2, then there's typically, if you're not running out of IOPS, there's no advantage in going to more IOPS. It's like a hygiene factor. It's like, it's good if I meet it, but it's not better if I exceed it.
Yeah.
Yeah.
Once you're clean, you're clean.
Sorry.
While choosing the EC2 instance, tenancy, which tenancy?
Oh, the question is, should I use the default, which is shared tenancy, or I own the whole box? If you have tons of money, own the whole box. But just about, the whole reason why you're going to the cloud is generally to lower your costs. That's a very big cost if you own the machine. So there really is no reason to.
I don't think I've seen a customer running dedicated personally for Tableau. It's always shared generally. Yeah.
All right, I see people hitting the door and we're over time. Thank you. If you have any more questions, feel free to come up.
Thank you.